The idea of stereo rotations or stereocenter rotations is that there are times when you're going to have to rotate a molecule in your mind. You're going to have to visualize how to rotate that so that you can determine if you have a new orientation or if you have a different one. And so we talked about in the previous video what are called R and S orientations. Okay? So what we're going to do this time is I want you to draw, because you're going to have to draw a lot when it comes to organic chem. So what I want to make sure you can do is visualize this in your mind. Okay? And this isn't so much the R and S orientation, but the idea that you have to be able to rotate things visually, right? You have to be able to do that in your mind. So we should be pretty good at drawing 3D structures here. Now what we're going to do is designate these by color, or at least by number here. So let's put our low priority guy in the back. We'll call that number 1. We can fit a number 2 and a 4 and a 3. So really all I'm going to show you is how to rotate this so that you can get the lowest priority atom in the back of the structure. So here, if it was an atomic mass of 1, then we have the right orientation. But there are times when you want to put this one in the back. Okay? So I want to show you examples about how that would work. So let's take this. We'll draw another central carbon here. And let's just assume that we drew the 4 in the back here. And I think we can fit that in. Okay. And the 3 stays on top. So the 3 would stay up here. Okay. And really all we did was took this structure and we rotated it about a central axis. In other words, we grabbed the 3 and we just rotated the front of this like that. Okay, and so now you can see 4 goes in the back, 2 goes to the right, and then the 1 now comes out to the front. And so that is another simple example about how to rotate something so that you can get the correct priority. Okay, and we could do it again, and we probably should. If we took the, and let's draw this here. Okay, let's take this, rotate it again, right? And we'll keep the 3 on the top. Right? And somebody's going to come out front. 2 of them will come out front. And then who goes to the back? Okay, so 3 is on top. And this time the 1 would come out and sweep in front. And you could even draw that if you want, right? Hopefully you can visualize that that 1 would sweep over there, 2 would go to the back, 4 would come to the front. So 4 goes there, 1 here in the front, and then 2 is now in the back. So now all we need to do is figure out a way to tilt this so that 3 would be in the back. That can be a little bit harder. Okay? How do you do that? You could do it a couple ways. Let's draw this here. Okay. You could tilt this so that you tip it backwards, for example. But what you really want to do is make it easy on yourself. Okay. So why don't we do this? Why don't we take this same structure here and let's make it, pick which one is ever easiest here. And if we, I don't know, let's try this. We're going to have the 3 up here. And if we put the 1 and the 2, right, let's put 1 here. Now 1 is going to be in the plane. I'm sorry, 3 should be up here. And then 1 is down here. Okay, so we've taken this diagram here. We're coming down in this direction. Okay, so 1 and 3 are in the same plane. Where does that put 2 and 4? Well, that's pretty easy to see. 2 would come out at you, and it was up here, but now we've just kind of rotated a little bit. So there's 2, and then we'll put 4 out there. Okay, there's 4, and then there's 2. Okay, so how do we get 3 to go to the back? If we tip it back, you can see that probably 2 is going to come way up here. So I don't know if that was helpful or not. If we tip it over here this way, then 3 is not in the back. Let's figure out the best way to do that. So let's take this diagram here. And if we tilt this, keeping 2 and 4 where they are, right? So 2 and 4 are going to stay right there. But this time we took this whole structure, and let's use blue like we did before. We can tilt this. We're going to keep these guys in place. So we're going to put them right here, and we're going to keep them on the ground. That way the 4 now, just like we did with mirror images, now the 4 is going to be in the back. So we can sneak 4 over here, right? But now the 3 is down on the bottom, and 1 is up in the air. Right now this 1 actually rotated up in the air, and we could do that, right? If you followed that, then 1 should be up in the air. And now the 3 must be here, in the same plane as number 1. And that's where you have to think a little bit. I'm sorry, this should be 3. Okay? And so this is the 2. Okay? Now it should be pretty easy because we've done this before. Now we can take 3 and put 3 in the back. Right? Because once you take this and you rotate it about that axis of 1, what happens? Now you can easily, hopefully easily see the 3's in the back. So we could draw it like this, right? 2 would come out at you here. 4 would be in the front. And then 1 would be up here. Okay? So that's basic ideas of how to rearrange these. So wait, yeah, let's make sure the 2 would come out here. Yes, okay. So that's just the basic idea, showing you how that if you have rotation, that sometimes you're going to have to put the lowest priority in a different place. So what you should do is practice with these. Let's try another one and see what happens here. Okay, let's start out with a different arrangement, and this time we'll go with orange. And this is really just practice. Some of us will see this very quickly, and others are going to need a lot of practice here. Let's say that 2 goes here in the back, and then we have the 3. And then 1 and 4 are actually in the same plane. All right? I don't think we need to do this, but we can talk about how if you rotate... Oh, I'm sorry. You didn't see any of that. Yep, take time to do that. Okay. So maybe we are asked to determine the R and S designation of this one, but it turns out that atom number 4, for example, right, this is the lowest priority. We're not going to talk about weight. We're just going to say lowest priority. Okay? But maybe that's hard to see here. Right? This is the clock face here, and we could probably do that. So let's practice that here. Let's call this high. This is the highest number. This is medium, and this is lowest in order of priorities. Okay? What do we call that? Do we call that an R or S designation? Well, if we can assume that this is the lowest, that this is to the back now, this high goes to medium. And it's probably readily visible to you that this would be an S designation. It goes counterclockwise or it goes to the left. If we need to, though, we could rotate this. So let's take this here, remembering 1 and 4 are in the plane, and we rotate it about that number 1 axle. Okay, what we get is 1 stays in place. Okay, 4 is going to be in the back, 3 is going to come out at you, 2, and so we'll draw 4. But let's designate them by their weights. We said 3 was a low priority. We said that 2 is a medium, and then number 1 is high. And so if we follow this by going from high to low priority, we go high to medium, right? And so immediately you see that that is what we call an S arrangement here. Okay? So really that's the idea, is just to practice this. Let's go back to make sure that we have it. The stereocenter really is about the idea that a carbon has 4 different substituents, or 4 things attached to it, and because of that, that has what is called a chiral arrangement, that it has a handedness, so there is a direction associated with it. The concern we have is that sometimes maybe we can't tell if we have the same molecule or if we have something different. In order to take care of that, we have what is called the R and S configuration. And so what we often have to do is put the lowest priority atom in the back. Well, these numbers don't really mean that that has the lowest priority, but let's do it this way. Let's say we had this arrangement. We would keep 3 at top, and then maybe we want to rotate that because number 4 might be the lowest. Okay? If in fact 4 is the lowest, you always put that to the back, and so that's what we have here. Okay? Then you imagine that the face of this is a clock, for example, and you go from highest to lowest priority. Okay? These examples here show how you do that. In other words, how to visualize. These were easy because they were rotated about the 3 axis, but here it's a little harder. What you do is you keep 2 and 4 in place, you tip that over. 4 and 2 now look like the mirror image that we had before. The 1 is now going to be up in the air, and the 3 is now down here. Then you can rotate it and put your 3 in the back. If 3 was, for example, the lowest priority. So if we had the lowest priority was the one on top, then that's how you would read it. Okay, we could do 2 rotations here. And finally here is just another example of how you would read the face from highest to lowest to determine orientation. The reason this is important is because when we have substitution reactions, we will have what is called inversion, and we will go between S and R designations.